Look, YB is working on his computer. He is thinking to himself, I have so many assignments to complete. The computer screen is a grid of thousands of tiny dots called pixels that together make up an image. Each pixel is represented by its coordinates. Now, look what YB is doing. He has opened Paintbrush application and drawing pictures. When he places the mouse at any point, we see the pixel position at the bottom of the screen. In real life, we see geographical maps that enable us to locate any place on the Earth with the help of the Earth's coordinate system, which is aligned with the spin axis of the Earth. Latitude and longitude form the Earth's coordinate system, called the geographic coordinate system. It enables every location on the Earth to be specified by a set of numbers. The airplanes and naval ships rely on the vast coordinates of the Earth's magnetic field for communication. How do you think the coordinates are plotted or located in all the above cases? Here, coordinate geometry comes to our rescue. It is used to plot or locate the points in a plane. Coordinate geometry is a branch of geometry in which a coordinate graphing system is made visible using points, lines, curves, and the numerical relationships of algebraic equations. Now, let us do a recap of the coordinate system that you have learned in your earlier classes. Horizontal and vertical number lines combine at their zeros to form a coordinate system which has 4 quadrants. Here, OX and OY are positive directions of XY axis, and OX dash and OY dash are negative directions of XY coordinates. So, the first quadrant is represented by plus, plus, second quadrant by minus, plus. The third quadrant is represented by minus, minus, and the fourth by plus, minus. This is the Cartesian or the coordinate plane where you can locate any point by its x, y coordinates. We call the x coordinate as its abscissa and its y coordinate as ordinate. Now, let us learn more about the graphical representation of 2 points by finding the distance between 2 points that lie on the x-axis. 2 worker bees, D and Lee, are at work in their beehives. If coordinate axis is drawn at a point, then the bees are at positions A and B in the beehive. Their distances from origin are OA is equal to 3 units and OB is equal to 6 units. When a point is on the x-axis, its y-coordinate will be 0. So, the coordinates of point A is 3, 0 and B is 6, 0, which is plotted on the coordinate system. We observe that the 2 points lie on the x-axis. Then, the distance of point B from A is equal to the difference of the length of OA and OB, which is equal to AB. Substituting the known values and simplifying, we get distance between the 2 points equal to 3 units. So, distance between 2 points 3, 0 and 6, 0, which lies on the x-axis, is 3 units. Both D and Lee have moved to new locations in their beehive. Can you find the distance between them? Points C and D lie on the y-axis, such that the measure of OC is equal to 4 units and that of OD is equal to 8 units. When a point is on y-axis, its x-coordinate is 0. So, the coordinates of points C, O, 4 and D, O, 8 are plotted in the coordinate system. We observe that the 2 points lie on the y-axis. The distance of point D from C is equal to the difference of the lengths of OC and OD, which is equal to CD. Substituting the known values and simplifying, we get distance between the 2 points equal to 4 units. So, the distance between the 2 points 0, 4 and 0, 8, which lies on the y-axis, is 4 units. Suppose the bees have moved from one position to another. Lee has moved from point B 0, 8 to D 6, 0. Similarly, the path traced by the second bee is along BD, where OD is equal to 8 units and OB is equal to 6 units, and OBD is a right-angled triangle. Applying Pythagoras' theorem to right triangle OBD, we get the value of BD is equal to 10 units. So, the distance of path traced by the second bee is 10 units. The distance between points with coordinates 0, 8 and 6, 0 is 10 units. Now, let us find distance of a point from origin. Suppose D moves to origin of coordinate axis, that is 0, 0, and Lee moves to position represented by point A 3, 4. What is the distance between them? The distance between them is OA. To find this, let us draw perpendiculars from A to P, which meets the x-axis at P, where OP is the measure of its x-coordinate and AP is the measure of its y-coordinate. Therefore, OPA is a right-angled triangle with OP is equal to 3 units and AP is equal to 4 units. Applying Pythagoras' theorem and substituting the known values and simplifying, we get the value of OA is equal to 5 units. What do you conclude from this? From this, we conclude that if P, x, y is a point in the first quadrant, then the distance of point P, x, y from origin is given by square root of x square plus y square. Now, let us find distance between points in different quadrants and not lying on any coordinate axis. Suppose D moves from origin to a point Q -6, -2 and Lee moves further to a point P 6, 3. Can you find the new distance between them? To find this, let us draw QS perpendicular to x-axis and also draw a perpendicular PT from the point P on QS extended. Then, the length of PT is the x-coordinate and the length of QT is the y-coordinate. PT is equal to 12 units and QT is equal to 5 units. Now, applying Pythagoras' theorem to triangle PTQ and substituting known values and simplifying, we get the length of PQ is equal to 13 units. So, the distance between points P 6, 3 and Q -6, -2 is 13 units. Can you arrive at a common formula to find the distance between 2 points P and Q which lie anywhere in the coordinate axis? Suppose point P is at x1, y1 and point Q is x2, y2 of the same quadrant in the coordinate system. Then the distance between them is represented by PQ. How do I use Pythagoras' theorem to find the distance between them? To find this, let us draw PR and QS perpendicular to x-axis. Let the perpendicular from the point P on QS is drawn to meet it at point T. Thus, OR is equal to x1. OS is equal to x2. So, RS is equal to x2 minus x1, that is equal to PT. Also, SQ is equal to y2. ST is equal to PR, which is equal to y1. So, QT is equal to y2 minus y1. Apply Pythagoras' theorem to right-angled triangle PTQ. We get PQ square is equal to PT square plus QT square. Substituting the values of PT and QT, we get the value of PQ is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is called the distance formula. So, distance formula is an algebraic expression that gives the distance between pair of points in terms of their coordinates. It is given by square root of x2 minus x1 whole square plus y2 minus y1 whole square. Look, D is now at position 1, 3 and Li is at 5, 6. How do you apply distance formula to find the distance between them? Here, position of D is 1, 3, which is equal to x1, y1, and Li is at 5, 6, which is equal to x2, y2. Substituting the values of x1, y1, x2 and y2 in distance formula, we get distance PQ is equal to 5 meters. So, the distance between the 2 points 1, 3 and 5, 6 is 5 meters. Now, let us apply distance formula to real-life situation. Determine the coordinates x, y for the cities A. Bangalore, Delhi, B. Chennai, Mumbai, and find the distance between the cities Bangalore and Delhi. On observing the map, x-y coordinates of the cities are as follows. Bangalore is equal to A 5.5, 5.5. Delhi is equal to B 6, 20. The distance between any two cities can be obtained by applying distance formula. We know by distance formula AB is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Substituting the values of x1, y1, x2 and y2 in the distance formula and simplifying, we get value of AB is equal to 14.50 units. Converting units to kilometers by using the scale 1 unit, which is equal to 142.52 kilometers, the length of 14.50 units is approximately equal to 2068 kilometers. So, distance between Bangalore and Delhi is approximately 2068 kilometers. Now, let us solve some more problems using distance formula. In a classroom, 4 students are seated at points A, B, C, D as shown in figure. Ria and Rita walk into the class and after observing for a few minutes, ask Rita, "Do you think ABCD is a square?" Rita disagrees. Using distance formula, find which of them is correct. To solve this, let us represent the 4 students on a rectangular coordinate system as shown in figure. On observing the seating arrangement, we find that position of A is equal to 3, 4, B is equal to 6, 7, C is equal to 9, 4, and D is equal to 6, 1 in the coordinate system. To check whether they are seated as a square, let us apply the distance formula. We know by distance formula AB is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Substituting the coordinates of the points in the distance formula, we get distance between students seated at points A and B is AB, which is equal to 3 square root 2. Similarly, the distance between points B and C is BC, which is equal to 3 square root 2. Distance between points C and D is CD, which is equal to 3 square root 2. And the distance between students seated at points D and A is DA, which is equal to 3 square root 2. What do you conclude from this? Here, AB is equal to BC, which is equal to CD, which is equal to DA, that's equal to 3 square root 2. As the distance between each of the students is the same, the students are seated in the form of a square. So, Ria was right. If the students are seated at points A 3, 4, B 6, 7, C 9, 4 and D 6, 1, then it forms a square. Prove that the points 3, 0, 6, 4 and -1, 3 are the vertices of a right-angled isosceles triangle. Let A 3, 0, B 6, 4 and C -1, 3 be the given points that are vertices of triangle ABC. We know by distance formula AB is equal to the square root of x2 minus x1 whole square plus y2 minus y1 whole square. Applying distance formula and substituting the known coordinates, we get AB is equal to 5. BC is equal to 5 square root 2. CA is equal to 5. What do you observe? Here, we observe that AB square plus CA square is equal to 5 square plus 5 square, that is equal to 25 plus 25, which is 50, that's equal to BC square. Also, the length of side AB is equal to CA, that is the two sides of triangle are equal. From this, we conclude that triangle ABC is a right-angled isosceles triangle with right angle at A. Find the center of the circle passing through the points 5, -8, 2, -9 and 2, 1. Let P, x, y be the center of the circle passing through the points A 5, -8, B 2, -9 and C 2, 1. Then OA is equal to OB, which is equal to OC, as the radius is equal. Applying distance formula to points O, x, y and A 5, -8, we get OA is equal to x minus 5 whole square plus y plus 8 whole square. Applying distance formula to points O, x, y and B 2, -9, we get OB is equal to x minus 2 whole square plus y plus 9 whole square. Similarly, OC is equal to x minus 2 whole square plus y minus 1 whole square. Consider relation OA is equal to OB. Substituting equations for OA and OB, we get x minus 5 whole square plus y plus 8 whole square is equal to x minus 2 whole square plus y plus 9 whole square. On simplification, we get 3x plus y minus 2 is equal to 0, equation 1. Now, consider other relation OA is equal to OC. Substituting equations for OA and OC, we get x minus 5 whole square plus y plus 8 whole square is equal to x minus 2 whole square plus y minus 1 whole square. On simplification, we get x minus 3y minus 14 is equal to 0, equation 2. On solving equations 1 and 2, we get x is equal to 2 and y is equal to minus 4. From this, we conclude that the coordinates of the center of the circle is 2, -4, which is equidistant from the points 5, -8, 2, -9 and 2, 1 that lie on the circumference of the circle.